In general, event-driven programming is a programming paradigm in which the flow of the program is determined by events such as mouse click, mouse press, messages from another program, or sensor outputs. Event-driven programming is especially useful in graphical user interfaces. In the example that I have just demonstrated, we can use the mouse to drag an image to another location. The mouse drag in this case is an event generated by a user. Although you may not be aware of it, the program is actually working behind this scene to track the movement of the mouse while updating the position of the happy face image. This kind of graphical user interfaces will allow such tasks to be accomplished easier. We are going to learn how this could be done in this lecture. In event-driven programming, program code is executed upon activation of events. An event can be a type of signal to the program that something has happened. The event can be generated by external user actions such as mouse movement, mouse clicks, and keystrokes, or by the operating systems such as a timer or an exception. In our discussion, we'll focus on events generated in a graphical user interface. In Java, the delegation event model is used for event handling. In a delegation event model, an event is generated when a user interacts with a graphical component, such as a mouse click on a button. The graphical component is called the event source. Once the event is generated, the event is passed or delegated to another object, which could handle the event. These objects are called event listeners or event handlers. In order to receive the event notification, listeners need to be registered with the source object. This is an effective way of handling the event because the event notifications are sent only to those listeners who are registered. The benefit of this approach is that the user interface logic is separated from the logic that generates the event. The delegation event model has three main components, namely event source, event listener, and event object. The diagram here illustrates the three components, and I'll discuss each of these in more details. The event source is the origin of which the event occurs. The event source is responsible for providing information of the occurred event to its event handlers or listeners. For example, we can set up a canvas as the source of the mouse click event. In the assignment that you are going to work on, the cannon object is designed to be a source capable of generating cannon-fired events. An event object contains the necessary information, including the event source and other event data for describing the event. For example, a mouse click event may include the XY position of the mouse on the canvas. A cannon fire event may include the orientation and the tilt angle of the cannon when it's fired. The event listener, also known as event handler, is responsible for generating responses to an event. The event listener waits until it receives an event. Once the event is received, the listener processes the logic of how the event should be handled. For example, the mouse click listener can position a color image at the XY position specified by the mouse click event. The cannon fire listener can move the cannonball to the destination position according to the orientation specified by the cannon fire event.